So what we're going to do, guys, is we are going to discover absolute zero using this little flask. And this flask has a pressure gauge on top. And we also have a temperature gauge hooked up to it. So if you look at this, here's the temperature gauge, okay? So what we're going to do is we're going to take this flask and we're going to put it in some hot water. And we're going to look at this formula, okay? Now we're going to take this flask, we're going to put it in some hot water. This water's hot. You can see this water is 66 degrees Celsius, so that's pretty hot. And when we put this glass in a hot place, when we change the temperature, we're going to change the pressure. Well, we're going to keep changing the temperature of our water by adding ice. And as we cool it off, we're going to see the pressure go down. And if we do this over and over, we'll be able to see how cold we have to be before the pressure gets to zero. And if that doesn't make sense to you quite yet, then watch. Here we go. All right, it's going to spill some. That's okay. All right, here we go. We're going to put this flask. We got to bury it all the way down in there. All right. We're going to put this flask. We're not worried about a little spill in some water. And push it all the way down in there. All right, so we've got this flask totally submerged. And as you can see, we're in water that is about 64.5 degrees, and the pressure is now 116.2 Kelvin. So we're going to write that down, like kilopascals. So our first temperature and pressure was 64.2 and 116.9 kilopascals, and that was in the hot water. Now we're going to cool the water off a little bit. We're going to put some cold water in it, some cool room temperature water in. Pouring out some hot water. I'm just going to replace it with some room temperature water. Okay, now we're going to go again. We put our flask down in here. Again, we're not worried about spilling the water. I don't care. Okay, and then we'll put the thermometer in there. All right.
Want to grab the fan?
Yep, and it's cooling off a little bit. The new temperature is 50.7 and 113.2. So we're going to write down a new data point. So now we're down to 50.7 degrees and 113.2 kilopascals. It's changed just a touch there, but there you go. So we're going to cool off the water some more and take another measurement. Cool that water off a little bit. And let's watch the temperature drop. Now we're down. See, we have temperature and pressure changing. Looks like we're locked pretty hard here at 39.8 and 110. Okay, I'm going to write that down, 39.8 and 110. Here we go again. Now we've got the water. We've cooled the water off a little bit more. I ran some more water from the tap in there, so we're cooling it off. Now we're down, you can see, 29.5 degrees Celsius and 106. All right, we're going to call this 29.6 and 106.5. Okay, now we just have room temperature water in there. We're at 23.4 and 104.4, or 23.5 and 104.4. So that's the next reading. So now we're going to try to make it colder than room temperature. So put a little ice in there. Okay. Look how scientific I'm being. All right. Some ice in there. Cooling it down even more. Let's see what we get here. We've got a little bit of ice, cooling our water down. We'll wait and see if we can find a nice steady point here. Dropping. Okay, I like that. 17.6 and 102. Okay, we're going to write that down. 17.6. So while Mr. Spear is adding more ice, I'm going to say, look, we've got these different data points, okay? And as the temperature goes down, 64, 50, 39, 29, as the temperature goes down, you're going to see also that the pressure is going down. Now we're going to graph this, so just stick with us. We're going to graph this and it will all make sense. Okay, we see the temperature is dropping. We've got a lot of ice in there now. You can see all the ice that's missing. We're going to see if we can find a stable temperature. We'll call this 3 degrees and 98. Okay, 3 degrees Celsius and 98 kilopascals. Okay, clearly we're on our last, we're down to our last try here because it's all ice. And you can see our flask is down in there. Our temperature, our last temperature we're going to get here, pretty chilly, pretty chilly. I'm going to say, get colder. I'm going to call this 1 and 97. All right, 1 and 97. We're going to write that down. Okay, so here's what we've done. We've made a blank graph, okay? And this is what Kelvin did. He made himself a blank graph with temperature in degrees Celsius and then pressure, okay? So we're using kilopascals. So our pressure is in kilopascals and our temperature is in degrees Celsius. So what we're going to do is we're going to plot some points up here. And our guess is when we can get down to about 0 degrees, when we can get down to 0 pressure, that is what absolute zero would be. We'll see how far back down this line absolute zero is. I hope that makes sense to you. We're going to plot some of these points right now. Remember, these are the points that we took as we cooled off the Erlenmeyer flask that was sealed up. So our first point was 64 and 116. So that's where our dot is. See, here's 100. So it's about up to 116, and here's 60. So we've made the first 3 dots. We've taken these first 3 points, and we plotted them up there on the scale. We're going to plot the rest real quick. So now we plotted all of these lines, okay? All of the dots. So here they are. And this is as close as we could get it. You can see the last one reads 1 degree Celsius and 97 kilopascals. So here's 100 kilopascals. We figure that's about 97. And here's 0 degrees Celsius. We figure that's about 1 degree Celsius. So if you back up, you can see we're starting to form a line. Now, Mr. Spear is going to hold this up, and he's going to try to do what we call a linear regression. We're going backwards from where we were. I'm going to hold this side for him. Okay, we're trying to make a mark going backwards. Now, we could have had the computer plot this, the little computer we were using, but I like doing it ourselves, okay? Now he's going to continue this line. We'll just watch him do it. We're performing a linear regression. We're going to continue this line. This is the first try, kids. Okay. Our marker's trying to go dead on us. That's all right. Bring it on. Bring it home. And he's finishing. And where do you think we should cross in a perfect world if we used all computers and did this perfectly? Where do you think 0 pressure would be? How far backwards? Well, it should be at 273. So we should have been right here. And we just missed about that far. So if you look at how long this line is and how small these little dots are, we did the line of best fit through our dots. If you do that, then you can see we did a really, really good job. This is a linear regression, and this is exactly what Kelvin did, except for he did it over and over and over, and the number he came up with, his best fit, after multiple experiments, was right here at negative 273. And he said, my name is Kelvin. I'm going to call this 0. And I'm going to start a new scale that goes this way. And we're going to call it the Kelvin scale. And we'll keep all of the degrees exactly how. What will all of the degrees in Kelvin be? That's right, they'll be exactly the same size as Celsius.